So part two, we're talking about the calculations of it. So we're using the mole to understand this. So this goes into our balancing equations. So our mole ratio is the conservation or conversion factor, sorry, not conservation, derived from coefficients of a balanced equation. So we must balance the equation in order to figure out the mole ratio. So what we do is we take our 1 mole, so we've balanced our equation, so 1 mole of N2 equals plus 3 moles of H2 equals 2 moles of N2H3. So by doing this, we know that 1 mole of N2 equals 3 moles of H2, which is a ratio of 1 to 3. Now we take our next ratio. We see that 3 moles of H2 equals 2 moles of NH3. So that is a 3 to 2 ratio. So knowing our ratios gives us our ability to figure out our multiplication or division factors getting to the next step. So we do this to figure out our next step. Now, you can use a mole map, but we will use our fence post method, so you don't have to worry about that. So 1 mole to 2 moles of NH3. Now we know how to do the multiplication factor. So however many moles we have of this, so we know we have 2 moles or amount of 2 moles of molar mass of N2, we would then multiply this one by 2 to get to this one. So that's what we do. Okay, and we will go through all of this when we get on your stuff or on your lesson. So that is knowing the mole ratio is step 2 of calculating our stoichiometry.